Hello again. I've built the most useless thing ever. I've built an integrated circuit mesh network. The reason this is fairly useless is because there aren't really many use cases for it. It's really slow, and the amount of code required to actually make the mesh network work takes up about 100 lines odd, which really only leaves you, 28 lines of code to actually put custom things in, which is not particularly helpful. So it's broadly useless, but it was fun. It was fun to build, it was fun to get working, and I'm going to show you how it works. So a mesh network, just in case you didn't know, is a network of nodes where each node connects to another node, which connects to another node, and then connects back to some original node, and creates a lattice of connections, and they all sort of talk to each other and can pass messages around. So in the example we've got here, and I'll overlay an image on this at some point showing the directionality of everything, but we've got 5 nodes. So you can see here in the middle, node 1, top right is node 2, bottom right is node 3, top left is node 4, and bottom left is node 5. And in terms of the connections, node 1 sends messages to node 2, which sends messages to node 3, which send messages to node 1 again. And also node 1 sends messages to node 4, which sends messages to node 5, and back to node 1. So on the screen right now you'll see a picture of that overlaid with arrows on it, showing you where everything goes. Also showing the connections of the devices. So you've got a dial down here and an LED connected to node 5, got a switch connected to node 1, and you've got an LED connected to node 2 and an LED connected to node 3. So what does this all mean? Well, I've put 2 functions in. So the idea is that on one of the circuits you put a message onto the stack, and then that message gets passed around to all of the other nodes, and the message contains an identifier of that message, an identifier of the function that you want to run, and then the content of the message, i.e. the kind of value you want to set for the function. So the functions that I've written are twofold. There's one function which will change the color of the LEDs, and there's one function which will turn them on and off. So those functions are defined on nodes 2, 3, and 5, because that's where the LEDs are connected to. So whenever a message with function number 1 or function number 2 reaches one of these nodes, then it will run that piece of code with the value that I've put in. So let's watch an example of this actually happening. Okay, so the first example I'll show is changing the color of the LEDs. So that is a function that originates from node number 5. So whenever I change this dial, node number 5 will send out a message saying, please run the function 9010 with the value of the dial, and that will tell the other nodes to change their color. So if we drop this to number 5, so there's number 5 on the dial, we'll hover over this middle node here. You should see some messages running through it. There they go. And you can see this one has changed to yellow over here already, which is color number 5. And then we have to start waiting for the other nodes to catch up. This is why it's very slow, because messages are being passed back and forth between these nodes, kind of handshaking. But we can see all of the LEDs have gone yellow. But it took a little while for that to occur. So basically what happens is this one will have a message, it will send it on to the next node, it'll do a handshake, so it'll say, are you ready? And this one will say, yes, I'm ready. But because each of those sort of requires a yield in between to make sure everything's updated, you get lots and lots of yields, and each hop you add adds another yield and another yield and another yield, so it takes a long time, which is why this is fairly inefficient. But you can see all of the LEDs have gone yellow, which is nice. So it did work. We sent a message from here to say change LED color to yellow, and it permeated through the network and they all changed. Right, let's move on to another example. Okay, so the second example I want to show is turning the lights on and off. So there's a switch up here which is connected to node number 1. So if we flick that switch, then we should start seeing messages. We'll hover over node number 2 and we should start seeing messages at some point appear in node number 2. This will, I think, also be going off from node number 1. There it goes. and then the lights will start turning on. There it goes, that light's on. That light's on over there. So you can see actually, while this one was working, this side of the network was also working, and then the delay for that one because the message being passed on to the third hop. Now all the lights are on. So you can see actually the message was sort of spreading out from the middle. Once node 1 had sent it, I think it sent it to node 4 to start with, and then it sent it to node 2. But once it's in these individual ones, then it's sending them on to 5 and 3 sort of in parallel. So it sort of starts to permeate out through the network, which is quite fun. So we can see all of the lights are now on, which is good. Just as a quick note, you can see on here I've got this screw is set to node 4, this screw is set to node 2. It doesn't actually matter what you set the nodes to in terms of the screw. The code just sort of loops through all the devices and only sends messages to other ICs. But what you do need to make sure of, and again I'll overlay the diagram right now, is that you don't ever have two ICs that talk directly back to each other. So for instance, you don't want node 1 talking to node 2 and node 2 talking back to node 1, because that will just get them stuck as they sort of wait for each other to handshake. You have to make sure there's at least a small circuit. So like in this instance, node 1 to node 2 to node 3 back to node 1. Otherwise it will all just get stuck. Right, let's do one more example. So the last example I want to show is two messages running at the same time. Sometimes this doesn't work. There is a bug somewhere. I'll have to find it and fix it. Something gets stuck somewhere. I'm not entirely sure how, but most of the time it seems to work. So let's give this a go. So first thing we'll do is we'll turn the lights on, and then we will change the color. So we should hopefully start to see lights turning on and lights changing color at roughly the same time, although different lights at different times. So we see a light on the left there has gone red and a light on the right there is turned on. Let's see what happens now. Okay, light in the bottom right has turned on. Light top right's turned red, so the messages are slowly permeating round. Light bottom right's turned red, so we're just waiting for, hey, here we go, the light on the left turned on, and that is all of the messages done. So that's good. All of the messages have made it round, and everything's turned on the way it should do, and the nodes are all back to their waiting states. So yeah, so you can see you can kind of have multiple messages permeating the network at the same time, but the more messages there are, the longer it takes, the more nodes there are, the longer it takes. So like I say, this is an entirely impractical solution. You'd never really use it for anything, but it was a bit of fun. It was interesting to see if I could get it working. There's probably efficiencies I can make in the code. In fact, there's certainly efficiencies I can make in the code. And maybe I'll try and do them, but it was pretty complicated to get working. So yeah, if you've got any questions, anything you want to see, then or anything you want to explain, drop a comment in on the video. But other than that, cheers. Thanks for watching. See you later.